Hi, this is Shahul Amit, Professor ECE, Sedu Institute of Technology. In this session, we are going to discuss a problem related to linear control engineering, in particular, Routh Criterion. First, I'll read the problem statement. Using Routh Criterion, analyze the stability of the system representing the characteristic equation s power 5 plus s power 4 plus s cube 2s cube plus 2s square plus 3s plus 5 is equal to 0. Comment on location of the roots of the characteristic equation. This is the given problem. Now we have to form a Routh array. So, now to form Routh array, we have to identify the coefficient of odd power and even power. So, in this particular characteristic equation, odd powers are s power 5, s power 3, s, and even are s power 4, is 1, and s square and s power 0, that is 5 into s power 0. So here in this particular problem, the highest power is s power 5. I am starting with s power 5, s power 4. So I am writing odd coefficients. So this is coefficient of s power 5, and 2 is the coefficient. This is the coefficient s power 5, and 2 is the coefficient of s cube, and 3 is the coefficient of s power 1. And then I'm writing even power coefficient, that is s power 4, this one, and then s square 2, then s power 0, it's 5. So first two rows we have written from the characteristic equation. Now we have to form the third row, that is s power 3. Here we have to find the first coefficient by multiplying 1 and 2 minus these two coefficients, that is 1 into 2 divided by this coefficient, that is 1, that is here 1 into 2 minus 1 into 2 divided by 1 is equal to 0. So first coefficient is 0. Then 1 into 3, then 5 into 1 minus 5 into 1 divided by 1. So here I have written 1 into 3 minus 1 into 5 divided by 1 is equal to minus 2. So this is minus 2. The main problem is the first value is 0. If you are continuing, that is forming the Routh array by simply assuming 0, then it is very difficult to find other coefficient, because anything by 0 is not a number, that is infinity. So we cannot use anything by 0. So instead we are simply replacing 0 with epsilon. Okay, simply I am striking 0 and using epsilon, and I am going to form the further array. So here the third row is here, and we are going to form fourth row. So now the same procedure, we have to multiply epsilon and 2, then minus 2 into minus 1 we get. So we get 2 into epsilon minus 2 into 1 divided by epsilon, we get 2 epsilon plus 2 divided by epsilon. Okay, this is the first one. So I'm just writing this equation, 2 epsilon plus 2 by epsilon. Then the next one is formed by these, multiplying these two things, epsilon into 5, and here we have to assume that 0 into 1, okay, divided by epsilon. So 5 into epsilon minus 0 divided by epsilon, which is equal to 5, because epsilon cancel, we will we have 5. 5. Now we have to form the next row, that is s power 1. So here the same thing. So we have to multiply these two things first, minus these two things, that is epsilon into 5 we get here. So first one is 2 epsilon plus 2 divided by epsilon into minus 2 minus 5 epsilon divided by 2 epsilon plus 2 divided by epsilon. Now I am just multiplying minus 2 inside the bracket. I get 4 epsilon minus 4 divided by epsilon minus 5 epsilon divided by the same thing, whatever I got this one. Now I am just cross multiplying this epsilon and I am finding the equation, that is 4 epsilon minus 4 minus 5 epsilon square divided by epsilon divided by 2 epsilon plus 2 divided by epsilon. I am cancelling epsilon and epsilon. The final equation is 4 epsilon minus 4 minus 5 epsilon square divided by 2 epsilon plus 2. I am just putting this value here, and then I am forming the next one, that is s power 0. I get, now we have to multiply this one and 5 minus, here we are as 0 into this one divided by this one. So here is a proof, 4 epsilon minus 4 minus 5 epsilon square divided by, that is this equation, into 5 minus 0. So 0 into anything is 0 divided by the same one. Now these two will get cancelled and the remaining is 5. So this 5, I am just putting 5 here. Now when we are seeing the first column of the Routh array, we are seeing this, except this one, all are positive. And here when we are taking minus outside, minus, we get minus 4 epsilon plus 4 plus 5 epsilon square divided by epsilon square divided by 2 epsilon plus 2. Here for any values of epsilon, for example, if you are putting epsilon is equal to 0, or epsilon is greater than 0, or epsilon is less than 0, the value is positive. Okay, this value is positive, and positive and negative is related. For any values of epsilon, this equation will give you only positive value. Okay, now in some cases, for example, if you are taking 0 and epsilon is greater than 0, it will give positive. In some cases negative, but we are going to take only for this case we are going to take epsilon equal to 0 and epsilon is greater than 0. For that case, the entire first column is negative. So we identified that there are two sign changes in the first column of Routh array, hence the system is said to be unstable. Okay, for any value of epsilon which is greater than 0 and 0, the first column of the Routh array is definitely is negative. Hence you can find sign changes, two different sign changes from plus to minus and minus to plus. So the system is said to be unstable. Here there are two sign changes happened. Because of that, we can say that there are two poles are on the right hand side of the S plane. That is, there are two roots in right hand side of the S plane, because there are two sign changes. Hence we can conclude that there will be two roots in the right hand side of the S plane. So the system is unstable, as well as there are two roots or in right hand side of the S plane. Thank you.